Hello everyone. Uh, so in this session, we have presenters from Saudi Arabia, Morocco, India, Colombia, and United Kingdom. So I like to say good morning, good afternoon, and good evening to everyone. On behalf of myself, Mihir Chauhan, and my colleague Disha Shah from Team World S4 2020. Welcome to the technical session 6C of the fourth World Conference on Smart Trends in Systems, Security and Sustainability, World S4 2020. Due to COVID-19, we all are going through a new normal phase, and the team of World S4 wishes you a safe and healthy time for you and your well-wishers. We are constantly trying to overcome the challenges that research community is facing at different level. We at Global Knowledge Research Foundation are fully committed to contribute and enhance the digital experience and research activities. To, to continue further with this conference, I would like to share that this time we have received a tremendous number of submissions, which has crossed more than 700 plus numbers from 40 plus countries through direct submissions as well as special session, out of which 142 papers were accepted by the technical review committee. So once again, we all would like to congratulate for you for your research work to be the part of this fourth international conference World S4 2020. Further, I would like to welcome our session chair, Dr. Nilay Singh Thakur. Uh, He is principal at Nagpur Institute of Technology. He has 26 years of experience. His research area includes image and video processing, advanced optimization, sensor and ad hoc network, pattern recognition, and data mining. So on behalf of the team, I welcome you, Dr. Nilesh Modi, Dr. Nilesh Singh Thakur. Do you want to share something with the authors?
Very good morning, very good afternoon, very good evening, everybody from Saudi Arabia, UK, and all other countries, from India also. Let's, Dr. Mir, we do start our session. That will be better.
Okay, thank you, sir. So we have our first presenter, Monzi, uh, from Saudi Arabia. So yes, Monzi, you can share your presentation now. The paper title is Virtual Prototype of a Wireless Sensor Node using VSDL AMS. Uh, yes, Monji, please try again. I have made you a co-host, so you must be able to set your screen. And you can unmute yourself as well. Hello, Monzi.
Yeah, hello, sir.
Yes. We can hear you. Please share your presentation.
Just for sharing my screen, how to do it exactly?
See, in the bottom of, are you using a laptop or a computer?
I am using my laptop.
Okay. So in the bottom, you will find there is a green symbol of share screen. Can you see that symbol, share screen?
Yeah, share screen, green.
Yeah, yes, click on that.
Okay.
And then, yes, perfect.
Is it like this?
Yes, it is visible. You can go ahead.
Okay, can I start?
Yes, please.
Thank you, sir.
Yeah.
So, thank you, everyone. I am happy to present our paper in the fourth World Conference on Smart Trends in Systems Security and Sustainability. I am Dr. Munji. I am from University of Monastir, Tunisia. Actually, I am within the Electrical Department, College of Engineering, King Khalid University. So we will present our work with the title Virtual Prototype of a Wireless Sensor Node using VHDL AMS. As outlined, we start first by giving an introduction. We present briefly the WSN architecture, its communication technology. We list the communication units, analog as well as digital components. By the end, we will show you the synthesis result and the system of the complete system, as well as the validation. We finish by conclusion and the future scopes. In the introduction, for our work, we present such an implementation using VHDL AMS, which is acronym of Very High Speed Integrated Circuit Hardware Description Language, Analog and Mixed Signal Extension. So here the implementation will present a virtual prototype, and it's not a real prototype. We just make a virtual prototype just to give an idea for the manufacturer or for some company to take some decision and some idea before start the process of manufacture. The virtual prototype in our work is modeled as an implementation on WS4 with the FPGA board, field programmer gate array. The validity of the prototype is verified by comparing bit or bit BAR curves obtained using the virtual prototype with the theoretical result for BPSK and BFSK signal transmitted over adaptive white Gaussian noise IWGN. The benefit of the virtual prototype is the development of mixed digital analog simulations and the use of graphical tools to produce a virtual prototype in shorter time and lower cost than a real prototype. Here we give the WSN architecture. We give the WSN architecture. In a given architecture, we have usually the general network, which is composed of some subnets. The fundamental unit in the sensor is the sensor, which is contained a capture unit that's composed that is composed with sensor and converter, and the processing unit, which contains a processor and memory. The second part, the communication unit, transmitter and receiver, and all these components are supplied by a unit power unit that undergoes or supplies all the previous parts. About the communication technology, it is the IEEE 802.15.4 that can support up to 65,000 devices, maximum data rate of 250 kilobits per second, allows distance between devices of 70 meters, operating in the unlicensed ISM band, and this table can give you more details. For the communication unit, we present here the main description of a given sensor node. It is shown that the sensor node consists in two parts, analog part and digital part. And for the analog part, or first for the digital part with the green component here, it's contain coders, code generators, spread spectrums. The model or to model or program this component, first the digital component, we have used the VHDL descriptions and modulation. The other part consists in the analog side that contains modulation, LNA, filters, etc. It was described using VHDL analog and mixed signal. The table below can give us the encoding type as well as the power consumption. It is in the development phase, we can use one of the three encoder. There is no difference in terms of power consumption. And here we look here that all the power consumption for the three encoder are approximately the same. Let's move to the power consumption of different coders. In this slide, we give the first figure gives the power consumption of the three different coders in terms of used cells in the FPGA. We note that here the differential coder, the first one means the differential coder can sum or take less component when uploading in a target devices like FPGA, for example. Next figure, this figure, it show you the PN code generator, how to generate the PN code that will be used to transmit a given frame. Here we focus on the analog part, which is composed of local oscillator operating with 2.4 gigahertz, multiplier, LNA, band pass filters, and AWGN channel. So here we make as an electrical circuit just to give a model for the analog part. It's like electrical circuit that can give a model for the analog part. Here we reach here the simulation results of the complete system using VHDL IMS description. Here we present all signals used in our description or on our simulation. It shows the spread spectrum signal, BPSK carrier, the second one, the modulated signal, LNA output, filtered signal, Gaussian noise, and the receiver input. Next, we give also the synthesis result of the complete system that contains both some digital and some analog component. The figure shows the used cells numbers as function of used component. The detailed circuit topology of FPGA synthesis is evaluated for each of digital functions in terms of number of FPGA cells used. It is noticed that PN generator implementation used the highest number of cells on the vertex 4 FPGA module. This is because it's authorized generation of codes ranging from n equal to 7 to n equal to 047. For the validation, here the validity of the analog and mixed signal simulation on FPGA synthesis is verified by comparing the bit error BAR curves of the simulated model with those theoretical BAR curves for BPSK and BFSK modulation schemes over AWGN channel using BPSK modulation over Rayleigh canal. The theoretical BAR of BPSK transmitter over AWGN channel is given by the following equation. So here the equation is given in the paper in the reference number 14. It can be noted that BPSK has better performance by 3 decibel as compared to BFSK to achieve the same BAR as BPSK, BFSK require 3 dB higher value of AB by N node. As a conclusion and the future work, here in this paper, a virtual prototype of a wireless sensor node operating in 2.4 GHz ISM band using FPGA synthesis, following most procedure as described in the ZigBee standard, has been made. The analog and mixed signal implementation have been implemented in using VHDL AMS language and integrated into Simplora package for system level simulation. As a future scope, in future work, we are ready to first improve this proposed design because there are many things to make an improvement. And second, we can collaborate with a specific manufacturer to design a real sensor node and get by sequence its behavior in terms of cost and power consumption. This is the main results for our contribution. And here we finish our presentation, and thank you for your attention.
Yeah, Monji.
Yeah. Yes, sir.
Am I audible?
Yes, yes, sir.
Yeah, I'm listening.
Yeah, just tell me, I'm
Yeah.
having 2-3 questions. You said it is working for n is equals to 7 to 2047. Why not it is working from 0 to 2047?
Which the infrastructure for the communication or what, sir?
Yeah, this one, this slide. Next one. Next slide.
Next slide, yeah.
Yeah, next.
This one.
Next one. You are next.
Next, okay.
You are going for previous slide. Next. Previous. Next.
Next, okay.
Hold. Here.
Here.
It authorizes generation of codes ranging from n equals to 7 to 2047. Why not 0 to 2047?
Why not 02?
2047. Why it
02?
is starting from 7? Why not it is starting from 0?
Yeah. This is we take from some reference. I don't know exactly why we start from 7, but it was taken from reference here.
Okay, the next question,
Yeah.
how many bits you have used? Previous diagram.
Previous diagram here.
No, you are going fast. Where you have shown those signals, BPSK signal, carrier, BPSK carrier. Yeah, this diagram. Yeah, previous.
Yes, back.
Yeah,
Munji,
Yeah.
it is slide number 9.
yeah,
Yes, perfect.
Chart
yeah.
number 9, yeah.
How
Yeah,
many
the
bits?
question.
How many bits you have used?
15 bits, sir.
How many?
15.
15 bits.
Yeah.
Then how are you getting the encoded signal with from n is equals to 7 to 2047?
Because each 15 bits, it's mapped with the details is given in the paper. Each 15 bits or each 15 bits is mapped with another number of some bits. So by the total or the result can give 2047.
Okay, have you when you are worked for this, have you gone through the constellation diagram?
Constellation diagram?
Yeah.
No, sir.
For BPSK, BFSK, as you have compared the result, you are getting better result in BPSK rather than BFSK. 3
Yeah.
dB, 3 decibel improvement is there, is it?
Yeah.
Have you gone through any constellation diagram related to BPSK?
No, sir. For constellation diagram, no.
Okay. Anyway, thank you.
Thank you, sir. Thank you very much.
Now the next one. Next one is Yasin Bent Lakshmi. Yasin is there. Yasin Bent Lakshmi.
Yes. Just a moment. Yasin, I have given you the permission to share your screen.
Okay, he's there.
Yes. Can you hear me?
Yes, sir.
Yes, perfect. Uh,
I will part. I will share.
yes, please.
Yes, you say.
Yes, yes. Please,
Yes, yes.
please go ahead.
Yes. Hello everyone. I am Yasin who will present to you his modest paper entitled Big Data and Spark comparison with Hadoop. My supervisor's name is Moulay El Hasnawi. We are from Morocco. I am in the first year of doctora. First of all, I want to thank you for all. The plan of this presentation is as follows. We start with a small introduction, then we will talk about the source of big data. After we will talk about the challenges of big data, and then I will present you the most famous framework in the field of big data, and I will end with the comparison between the two, Spark and Hadoop. What is big data? Big data, which by name tells, is the term of a collection of data sets so large and complex that it becomes difficult to process using hand database management tools or traditional database processing application. Yes. So in this table, you see the difference between traditional database and big data. For query in big data, largely abandoned SQL. In traditional data, in traditional database, traditional SQL. Architecture in big data, distributed in traditional centralized. Data type. Big data supported structured, semi-structured, and unstructured, but traditional support just structured data. For data model, in big data, no schema. For traditional data, fixed schema. In data relationship, in big data, you know now on complex, in traditional data, now or complex. Data volumes in big data, petabytes or exabytes. In traditional data, just terabytes. Data traffic in big data more, in traditional data less. Data integrity in big data less, in traditional data high. In this, there are several sources of big data. When we send an email, we generate big data. When you connected to social network, you generate data. When we deposit the money or we make the withdraw, we generate data. Therefore, each operation generates data, which created challenges to solve in the field of big data. There are several problems with big data where researchers focus their research on overcoming them. For example, as you say in the slide, management issues, storage issues, processing issues. Management issues. Big data management is the collection of large amounts of structured, unstructured, and semi-structured data from any organization of system. Due to the size of data management is not an easy task and it requires a lot of workforce to handle it. Storage issues. By 2020, more than 1 megabytes of new info will be created every second for every person. You can't store this much big data into your traditional RDBMS like Oracle, MySQL, or MySQL SQL Server. Several tools are proposed by the researchers, but these tools still need the work to overcome this problem. Processing issues. Processing is a very big challenge as the data is present in difficult format. It can be structured, semi-structured, and unstructured. Analyzing unstructured data using our traditional RDBM is impossible. To overcome these challenges, researchers are developing and further improving big data tools. The most important executive in this field are Spark and Hadoop, Apache Hadoop. What is Apache Hadoop? In general, Hadoop is a software framework for storing, processing, and analyzing big data. Apache Hadoop, as you say in this slide, the characteristics of Hadoop are distributed, run on multiple machines, scalable. We can add several machines to have a good performance. Fault tolerance. If a machine falls down, the system doesn't not suffer. Open source. We can have the source code to modify it. Apache Hadoop, the most Hadoop is made up of two main components, HDFS, Hadoop Distributed File System. The HDFS is a file system written in Java that work on any operating system. You can say it's like JVM. The role of HDFS is to store the data on the cluster. The data is divided into block of 16.4 megabytes or 128 megabytes and distributed on several nodes of the cluster. MapReduce is a clustered data processing framework composed of the map and radius function. It makes it possible to distribute data processing tasks between different nodes or computers in order to then reduce the results into single summary. Voilà. Spark, Apache Spark in this technology that is being used by all the industry leaders to do real-time analytic. Spark streaming is used to stream real-time data from various sources like Twitter and perform powerful analytics to help businesses. The Spark ecosystem. Along with the main Spark API, the ecosystem contains additional library that allow us to work in the area of big data analytics and machine learning. Among this library, we find Spark Streaming, Spark SQL, Spark MLib, Spark Graphics. Spark SQL. You say the schema of the Spark ecosystem. Spark SQL. Spark streaming can be used for real-time processing of streaming data. It is based on a micro-batch processing mode and uses for real-time stream data. That is to say, a series of RDD, resultant distributed data set. Spark SQL allows you to expose Spark dataset via JDBC API and execute SQL like query using using BI and visualization tools. Spark SQL allows you to extract, transform, and load data in different formats, JSON, Parquet, database, and exposes them for ad hoc query. Spark MLab is a machine learning library that contains all the classic learning algorithms and utilities such as classification, regression, clustering, collaborative filtering, dimension reduction, in addition to sub-optimization primitive handling. And the last Spark Graphics is the new API in alpha version for graph processing and graph parallelization. Graph extend Spark RDD by introducing the result distributed dataset graph. Now, since you have got an overview of both these two frameworks, let me move ahead and compare Apache Spark with Hadoop on different parameters. To understanding their strengths, we will be comparing these two frameworks based on this parameter. Let's start with performance. As you say, Hadoop is slower than Hadoop. Spark is faster than Hadoop. Why? And the method used by Spark to process the data make it much faster than MapReduce. While MapReduce works in stages, Spark can work on all of the data at once. MapReduce works sequence looks like this. It read data at the cluster level. It performs on operation. It writes the results at the cluster level. It read the updated data again at the cluster level. It executes the next operation. It writes the new cluster level result, etc.
Sorry, Yasin, but please conclude in 2 minutes.
Yes, yes.
Thank you.
Yes. Okay. I will conclude.
Yes, please go ahead. You can explain conclusion. No problem.
It is true the Hadoop to overtake big data default like storage, processing, etc. But the data has been increasing with great speed. So you have to try to find another way to approach big data tools. My future work is to optimize MapReduce through ant colony optimization and machine learning. Thank you for your attention. Yes.
Yes, thank you, Yasin.
Okay,
Yes,
thank
Dr.
you,
Nadesh.
Yasin.
Yes, sir. Do you have any question with Yasin?
Yeah. Yasin, are you hearing me?
Yes, sir.
Just tell me which parameters you would like to optimize when you are using MapReduce, because you have mentioned in a future work you would like to go for ant colony optimization. On which parameters you will focus on for the optimization?
I will focus in at reduce function.
Pardon?
Reduce function.
Rajesh?
Function. MapReduce contain two function, maps and reduce. I will try to focus in reduce function.
Okay, thank you.
Thank you, sir. Thank you, sir. Good night.
Good night.
Okay, thanks a lot, Yashin. So we move ahead with our next presentation. Next presentation will be by Upasna. They will present a paper on big data and Spark comparison with Hadoop. So,
No, no.
sorry, IoT based smart plant incubator.
Sir, am I audible?
Yeah,
Yes,
yeah, yeah.
Yeah. So I'll start.
yes, please.
Good evening, everyone. I hope every one of you is safe in this difficult pandemic time. I'm Upasna Thakuria, a student from the Department of Electronics and Telecommunication in Sardar Patel Institute of Technology, India. I hope all of you find this presentation interesting and informative. The topic of the presentation is IoT based smart plan incubator. Also, actually, I'm unable to change the slide.
No, no, no.
Technical
It was
issue.
changed. It was changed.
Uh-huh. Yeah, sir.
Scroll it.
Yeah, sir.
Right now, only title slide is appearing.
Yeah,
Just
sir.
scroll.
Now,
Now it is changed.
yeah. We'll proceed in the following chronology: the introduction, problems people face, the objectives, the components, the flow diagram, methodology, simulation and results, future scope, and conclusion and references. Life as we know would not be possible without plants. Different plants have different requirements in order to grow properly, like different ranges of temperature, different humidity, and different light intensities. There is a diverse pattern of climatic and environmental conditions, as a result of which factors such as the rainfall, the soil, temperature conditions may vary significantly all over the world. This unexpected and unsustainable rainfall and climate in turn makes it very difficult for the sustainable growth of plants. As a solution to this, we have developed a smart plant incubator which simulates the nearest possible environmental conditions for a plant inside a single unit for the improvised sustenance of the plant. It is a fully automated IoT enabled unit. The key feature is the ideal ranges of the temperature, air humidity, and light intensity for a given plant that can be set up as well as monitored in real time. Moving on to the next slide, I would like to point out some of the problems that people face. The people in the agricultural sector, like the farmers, suffer drastic losses every year due to natural disaster in spite of investing a lot of money and efforts in the cultivation of the land. Secondly, the farmers also are depleting the soil fertility and productivity by using more and more synthetic fertilizers and pesticides in order to obtain the optimum condition results with the crops. In order to overcome such situations, the farmer should be able to cultivate and harvest the commercial crops without having to worry about any varying environmental conditions. Our incubator is a good fit for that. Moving on to the next group of people are the R&D people. The people in the R&D sector often require to experiment with different set of external parameters as well as require the ideal condition to work on the development of the plant genetic evolution. The third group are the medicinal industry people who want to grow the medicinal plants but could not due to unfavorable geographical constraints. The last group are the people who want to grow the exotic plants under normal conditions that would not grow in their area. Providing a solution to all of these problems, our incubator offers the plant specific favorable condition with an option to select from a wide range of parameters. Next are the 6 main objectives of our project. The first is incubation of plants according to their required temperature, air moisture, and light intensity. The second is the better growth of plant within a shortened time span due to adjustable lighting and temperature controls. The third is the less human interaction required for caring and growth of plants due to increased automation. The fourth is the incubator is reusable and a wide variety of plants can be used because of its flexibility in temperature in the range of 18 to 40 degrees Celsius and flexible air moisture range. The fifth is the organic produce, as the plants inside the incubator would be free from the unnecessary pesticides and the fertilizers. The last is the real-time smart tracking of the parameters made possible via the cloud interfacing. The next are the components list with their model names. As we can see in the list, the components are the CC3200 launch XL microcontroller, the temperature and humidity sensor, the current sensor, the soil moisture sensor, exhaust fan, TC Peltier model, water pump, and LED light source. Now we arrive to the flowchart diagram, which shows the connection of various sensors like the soil moisture sensor, temperature sensor, and air humidity sensor to the microcontroller and Wi-Fi module CC3200. As we can see, the other components that are connected to the base circuit are the ultrasonic sensor, which is used to measure the water level, the water pump, cooling and heating fans, and the blue and red LEDs to provide artificial sunlight. The Wi-Fi module is further connected to the AWS cloud via the MQTT protocol. The next slide is on the key concepts that we have used. The first is the CC3200 Launch XL module. It is used for sending the sensor values to the cloud as well as receiving the parameter changes from the cloud after the parameter tweaking is done. The second is the MQTT protocol, which stands for Message Queuing Telemetry Transport, that is used here as an IoT agent. The communication between the hardware and AWS is done by sending or receiving the command or data using different MQTT topics. Now the third is the Amazon Web Services, that is AWS platform. For this project, we have created an instance on AWS and started a Node-RED service on Ubuntu OS. We also have our MQTT broker that is running on this AWS platform. Next is the methodology of a project. The CC3200 module is interfaced with all of the mentioned sensors and actuators. The input data is received from the temperature, moisture, and humidity sensors, and then it is sent to the Node-RED dashboard on AWS. The communication between the hardware and the AWS cloud is carried out using the MQTT protocol. The monitoring and controlling of data is achieved by logging it into the cloud dashboard. The values of the required temperature, humidity, and soil moisture level, as well as the light intensity, could be different for different plants, which is manually configured by the user. This is the EDA schematic diagram of our prototype simulated on the Eagle software. The motor 1 and 2, labeled as 1, are the two exhaust fans. The two L293D, marked as number 2, are the two motor drivers, which take 5 volt as an input to give 12 volt at the output. The current sensor is labeled as 3. The soil moisture sensor is marked as 4, while the number 5 is the DHT humidity and temperature sensor. Number 6 is the LM35 temperature sensor. The 7th is the power supply, while number 8 is nothing but the Atmega 32820P, which the CC3200 microcontroller functionality equivalent of on the Eagle software library. Moving on to the basic prototype design, we can see there are 3 sections of the incubator. The first, the upper hub, housing the connection between the circuit and the sensors. It also houses the red and the blue LEDs that are used for artificial lighting. The second being the middle insulated space with the vents for air transfer. The third is the heavy bottom layer consisting of the soil and water storage tank. The incubator tank components and their functions are as follows. And the components are the waterproof tank, the two dividers, the LED holder, the foil wrapped at the inner walls of the tank, mineral wool, water pump, and LED light source. Now, this is the actual prototype that we have designed. As we can see in this diagram, we have used a waterproof plastic chemical container as the body. We have used two dividers to divide them into the three compartments. As seen in the diagram, the CC3200 microcontroller and the temperature humidity sensors are located in the upper compartment, which also houses the red and blue LEDs. Furthermore, the inner walls of the middle compartment are coated with the mineral wool for insulation purposes, which is further covered by aluminium foil for reflection purposes. The exhaust fan is located in the lower compartment and it is used for providing ventilation. In the simulation and results, we have the control dashboard that we hosted on AWS, and it is used to manually set the temperature, soil moisture, humidity, lights and intensity parameters, and it is even used for switching the exhaust fan on or off. Similarly, we also have the monitoring dashboard for the users to view the parameters remotely from any place at any time. Next is the future scope. Now, this smart plant incubator could replace the traditional greenhouses because unlike them, the incubator could even sustain and grow the seasonal plants throughout the year as well as the exotic plants at any place. It could also reinforce the fully automated smart nursery concept, eventually contributing to a smart city. To conclude, I would like to highlight some of the unique value properties of our product. The incubator is remotely controllable as the systemic data reception from the sensors and the parameters tweaking is done efficiently using IoT. All of these are performed in real time itself with slight network delay. The next is the less human interaction due to the automation, which is made possible by the sensor AWS cloud interfacing. The third is there is no harmful byproducts released, making it eco-friendly. The fourth is the higher and better yield of the products due to incubating them with their optimum temperatures, moisture, and light intensity ranges. The fifth point is that it is portable and compact, and it is easy and travel friendly. The last but not the least, it is affordable as compared to the highly priced plant incubators currently available in the market. These are the references that we have used. Thank you for being here today. Really appreciate your time here.
Yes, thank you, Pasna. Yes, Dr.
Yes,
Nalin
sir.
Singh.
Yes, Upasana.
Yes, sir.
Now, in your plant incubator, uh, it's not clear to me how the light intensity care have been taken.
Yes, sir. This was handled by Ashay, so he would answer the question for you.
Hello.
Uh-huh.
Yeah, please.
Yeah. Sir, so the question is how is the light intensity handled, right?
Right.
So, okay, so it is we have used L29 3D, which converts 5 volt to 12 volts, or we have used spot also to regulate the flow. If the LED gets more than 7 volts, it gets started with a very low intensity, and as you increase up to 12 volts, it is the maximum intensity of the light.
No, no,
So,
it's okay. But that light is which light? Whether it is a
DC.
sunlight?
No,
No,
DC LED light.
is it? It is not a sunlight.
No,
Fine.
no, no, no,
But
no.
for the growth of the plant,
Yeah, yeah,
some
yeah.
different ingredients are required. Is it?
Yes, sir. Yes, sir.
Soil
So,
has the different property.
yeah,
If you are pouring a more water, it doesn't mean that the plant will grow fast. It should be managed in a proper way. Likewise, the sunlight intensity should get
yeah.
managed.
So we have used the red light and the blue light. So the red light is yeah, used by the plants for their growth and by the in terms of height, and the blue light is in terms of the width. So we have adjusted the parameter of the red and blue lights in the ratio of 2:3 of red and blue, and so we have kind of tried to manage the uh, growth by that
Okay,
way.
let me tell. You have designed all this, okay? Because one diagram you have shown
Yeah, yeah, yes,
that cylinder sort of box
yeah, yeah,
was
right,
there.
right.
So have you experienced the growth of the plant? For how many days you have experienced?
So we tried that for as a project. So we tested it for like 10-15 days, and it was growing with a normal rate. Like there weren't any problem, but we also used a normal plant. We haven't tried it with some exotic plant yet. So
Yeah,
that's in
because
under development.
it is very much important when you talk about the yields.
Yes, yes,
Like when you talk about the yields, you know, lot many fertilizers and all that the farmers are using
yes,
just
yes,
to have the good growth and good yield. So
yes,
you have tried well. That is not the issue, but it should get more generalized, because unless until if your design is not acceptable publicly, because you do have the more number of customers, is it?
Yes.
So farmer is the best customer for you. Okay, thank you.
Okay, sir. Thank you,
Okay.
sir.
Okay.
Thank
Thank
you,
you.
Upasana.
Thank you, sir. Thank you, sir.
Okay. Thank you, everyone. If anyone has any query with the team, with this team, you can ask in the chat. Um, so we move ahead with our next presentation. It will be by Satish. The paper title is Multiple Heart Disease Prediction Using Logistic Regression with Assemble and Hyperparameter Tuning Techniques. Yes, Satish, now you can share your presentation.
Hello,
Yes, Satish.
is my screen? So is my screen is visible?
Not yet.
One minute.
Yes,
One,
Satish.
1 minute, 1 minute. Like actually, my Mac system is asking some.
Okay.
Okay, so is it fine now?
Just a moment.
Yeah.
Yes, yes, you can share your presentation now.
Yeah. So visible now? Fine.
Yes.
Okay. So fine. So shall I start? Okay. Good evening, everyone. My name is Satish Ambashandar. So I'm representing from Pragyan AI School, and my team is Vijay Lakshmi A, Sridevi S, Dr. Venkateshwaran, and Dr. Yashoda. So our paper is about identifying multiple disease herd disease prediction using logistical regression with optimized with assemble and hyperparameter tuning techniques. So Okay. The problem statement, what we are trying to address is actually in India, around like 28% of the people will die with the heart disease, up to around 2.8 millions every year. So it was the statistics is in 2016, and it was from every year it is keep on increasing. It was 15.2 in 1990, so it was keep on increasing, and so many people are trying to do research on predicting. So the main reason for going ML kind of algorithm, and a lot of research is happening in ML, is actually the a lot of research happening to predict early about the heart disease or heart, the possibilities of strokes actually. And we also worked on build several models using ML to achieve something like accuracy up to 100%. So, and I will discuss actually, like this paper explains the stepwise approach how we built the 7 models to achieve that accuracy, and also our future scopes. So the prior works, what we referred is actually, these are the papers like IEEE papers attempted to build a ML model for heart diseases. So, and what we observed is actually like there are some Kaggle notebooks also we referred. So the accuracy is something 73.5%, and in reference to, so we found it's 85.24, reference 3 something. And in research paper, like not only logistical regressions, there are paper in neural networks, KNN, SPM, and DFT in random forest. So it is the maximum achieved is so far is actually 95.91 so far what we referred actually. And to build a model, we use the data set, UCL data set. This is a standard data set actually. So US based institute, which shares most of the healthcare data sets. So most of the any healthcare kind of design or model, whether it is a ML or a CV based model, so they will use a UCL data set. And we also use that. It has around 303 patient information and 13 parameters, health parameters, and the 14th is a target actually, the classification level. So ES, sex, and chest pain and all things are there. So, and we used algorithm, logistical regression. So there is the blue line is about linear regressions, and we use the logistical regression. We use the logistic function, and it gives something like a S kind of curve. So I think the development environment, what we used is actually Anaconda software, and we used ML libraries, scikit-learn, and programming and Jupyter. And for visualizations, we used Matplotlib, Seaborn, Plotly, and this normal system actually. The approach, our building approach actually, like we started cleaning the data, so cleaning the missing value and doing the univariate and multivariate kind of analysis, and we checked is the data set is balanced or not. So if the data set is balanced, then the approach is different, and if the data set is imbalanced, then we have to work how to balance it actually. But the data set what we used is actually balanced, so we are not anything here. And we did in univariate analysis, we looked for the distribution skewness, kurtosis, and is there any outlier presence in that. So what we found is actually some of the parameters, like, so this is the one parameter where we found some kind of skewness. Like, so if you see here, it actually, this is rightly skewed actually, and there are some outlier presence are there. And here also, if you see that, like, there's a skewed one and some outliers are present there. So we observed actually there is some outliers, and we used boxplot to further validate actually there is a presence of outliers are there, suspected outliers and whisker outliers. So we found there are some outliers are there. So after founding the outliers, like, so what we like, this is another parameter. So after founding the outliers, like, we try to use there are several methods to remove the outliers. Like, we use a turkey fence method, but we modified the, instead of like standard 70 IQR range from 75 to 25, we used 85 and 15% actually. We changed the IQR range, and the turkey fence formula we used and we removed the outlier, and then we checked actually like how the distributions looks like using following algorithms, and we see that like still there is outlier presence or not. So that and I have only shown one parameter, but there are several others. So several parameters we checked and we draw the diagram, and after reviewing the outliers, and this is all about the univariate analysis, and we did the multivariate analysis like correlation matrix. Like, so we want to see that like how these parameters are correlated each other, because if they are highly correlated, we don't need to use them for prediction. So we did the correlation analysis. Not only correlation analysis, like we also did several other feature selection that I will explain later on. And we also use hyperparameter tuning methods using a grid search and random search methods. And these are the parameters of logistical regressions we tuned: penalty, L1, L2, and the sort, the kernel, what it has to be used, and max iteration, and the random search. These are the key parameters we fine tuned using the grid search and random search to optimize our model. So, and to transfer, since we got the outliers, and we got we found that there is a skewness in there and kurtosis is there in the distributions, and we tried multiple data transformation methods like standard scalar, Robert scalar, quantum scalar, and power transformers. So in one is box cost method, another is what we used is U Johnson method. So we got good result in Joy Johnson method, but this is also good method actually we are getting, but like that are not reflected in the model. But these are the methods we tried, and we also tried some kind of ensemble method boosting, bagging, and sampling, and cross validation. So the cross validation is used to check actually like we are not particular only specific kind of test and training set. We should not be getting the good results. So we use the cross validation, and we used also k-fold method. So these are the methods we use. And apart from this, like we also used something called feature engineering. So there are two things we used here: feature selection. The reason why we have to do feature selection and dimension reduction is actually like, as we know that like the number of columns, like number of features increases, the dimensionality of the problem is like to optimize it actually. If it is a features are there, then it is a 4D kind of model. If it is a 5 parameters, like, so as the dimension increases, then complexity of computational power it needs is more. So so what we tried is actually we first optimize the performance, and then we try to reduce the features which is not essential, which is not influential to useful to predict the diseases actually. So we use feature selection, like we use the correlation matrix, we use the random forest or extra try, and there is also one more method we use I have not mentioned here, is actually logistic regression approach also we use to find out which features are important for this model. And then finally we use dimension reduction after selecting features. Like we use the dimension reduction methods like PCA and kernel PCA, and here we fine tune the kernel parameters actually. The kernel PCA use multiple kernels, so we hyper tune for which kernel parameters it was giving good result. So these are the methods we use, and this is what we got the feature importance actually. If you see that like this is the highest, target is highest, so the THAL and CP, and if you look at actually if FPS is lowest, and rest T rest ECG and sex, all these sex means like gender actually, male or female. So these are the low importance something. And if you see here cumulative feature importance, if you see actually like 6 or 8 or 10, so it is increasing. Like, so if you look at actually 90% or something, that like around 6 or 8% feature is more than enough to predict the model. So that is what we got. And to evaluate model, like we are not only dependent on the accuracy, so we also looked into confusion matrix, recall.
Yes,
Yeah.
sorry, Satish, but please try to conclude in 2 minutes. Yeah.
Yeah. So fine. So recall, precision, and F score. So we did that actually, like multiple methods. And uh, what we did is actually like these are the model one we built. So using the basic cleaning things, like so first we tried actually only the just data cleaning, then hyper tuning, then like next step is actually using the power transformation, what is the accuracy we got, and then one by one actually, like, so we in model 4 we reached actually 100% in across all parameters, and then we started reducing, the features and dimension reductions, like, so model 5 to model 7 we did that actually. So this is the result table. So seven models we built actually, and this is like in terms of algorithm, pre-processing, feature engineering, parameters, like, so what all things we did actually, this is what is the result. And as our conclusion, to conclude it actually, like, so to build an effective model, like, we should be starting with univariate and removing outliers and this something. So the key thing is here actually, we use the turkey fence, and we use the data transformation, and we first achieved 100%, and then we refined, reduce the features and dimensionality. So that is the thing. And feature scope is actually like, so now we use UCL data set. So we wanted to test with multiple different data sets, and we also wanted to build a different algorithms. Not only we build logistic regression, we wanted to build different algorithms. And then we wanted to check actually like how this model behaves with the parameters what we receive from smartwatch or smartphone, so that like from those parameters are we able to predict what are the basic parameters like BP, heart, ECG, and all those things, like, so whether this model is works with that also. And this is a scope feature, and then the live data, the real data, it's like from medical hospitals, we wanted to collect data and see that like how this model is performing. This is the future scope of the model. So thank you.
Yes, Mr. Satish.
Yeah.
Hello.
Hello.
Yeah, just tell me how many number of records you have taken, that data records for your complete model implementation.
I think I have shared here, like, so the data set is, let me show again. So this is 303. So this is the standard UCL data set. So it has the 303 patient information with 14 features.
Okay, 303
Yeah.
along with the 14 means your matrix size is 303 by 14. Is
Yeah,
it?
yeah. So 13, 14 is the target. So the classification, but is 3 by 3 into 4, 13.
13. And how many classes?
How many?
Classes? Your
Classes is
target?
only only two actually, like,
Only two.
yeah. So there what we did actually, there are multiple like mild, severe, and heart attacks. So what we did it actually, like, we said either the possibilities of heart disease or not disease. There is the 4 classes were there that we optimized into 2 classes, whether that possibilities of heart disease or not disease. So,
Rather you haven't optimized it, you have made it to only 2 class. In place of that 4 class problem, you have made it to 2 class problem with the 13 features, is it? And 303 records you were having in
yeah,
your
yeah,
implementation.
yeah, yeah,
Okay,
yeah,
am I right?
yeah, yeah. No,
Okay.
it is, yeah,
Hello.
Yes.
yes, yes.
Just tell me, you gone for the principal component analysis.
Okay.
You went in a model number 4,
Yeah, yeah.
4 or 5, 5. In model number,
Four onwards, principal component analysis.
so till how many features you have reached? 7 features out of 13.
Like finally, the final is optimal is model 6 with 4 features.
4 features.
Yeah, yeah. So means like
Have
not
you,
four
have you
features
got
actually.
have you got
Not
any false?
four. No, no, no. There is this is not a 4 features actually. The features, like the feature selection, what we reduce the number of features is only 3 features we removed actually. But principal component will calculate the different features, not the same features what is there in the data set. So the finally 4 features.
Finally, you reached to 4 features. Have
Yeah,
you
yeah.
got any false positive results?
So you see, it is there actually 0, 0.
0, 0.
Yeah, yeah. So 100%, no? So 100%. We in precision, if you look at actually like the precision and recall and F score and support like those, so this is 100% is there.
Getting 100%. Have you evaluated R square error?
Yeah. R square
How
also
much?
the same. So
How
R
much?
square also is there no, here like R square I have not done actually. R square we not done. ROC curve we calculated.
No, I'm talking about R square error.
No, R square we not done. R square done we not done.
Okay, thank you.
Because we did precision recall, F1 score, and ROC curve and accuracy.
Okay, thank you. Thank you.
Okay, thank you.
Yes, Mir sir, next.
Yes, Alexander has question for you, Satish. Please. Yes,
Please.
yes. Sir.
Can you tell me, did you try to use the artificial intelligence tools, for example, neuron networks, deep learning, cognitive modeling? Because you use only a regression analysis. But I think that neuron network or cognitive modeling, have you heard about this something?
Yes, Satish.
Yeah, I'm sorry. Hello.
Yes.
Yeah.
Have you listened the question, Satish?
Works correct.
Have you heard my question?
Can you repeat actually? So.
Okay, the question. Did you try to use artificial intelligence tools, instruments, algorithms, for example, deep learning, neural network, or cognitive modeling for your decision? Do you understand? Artificial intelligence. Have you heard anything about it?
Hello, Satish.
Hello.
Yes, have you heard the question?
Yeah. So, okay, I will tell you, apart from these logistical regressions, we also build 100% accuracy in neural networks. We also build the RF random forest algorithms. We also so we have built several models, like we only presented logistic regression here, but we build with several other models, algorithms also using ANN. So artificial neural networks also we built. So we got the 100%. Like around 10 models, 10 algorithms we use optimized for all 10 algorithms. We got 100% accuracy. In that, ANN is also there.
Thank you. Understood.
Okay, thank you.
Okay, thank you.
Sorry.
Okay. So if anyone has any question with Satish, you can put into the chat, so he will answer you in that, or you can exchange your email address as well. So we move ahead with our next presentation. It will be by Tanmay. The paper title is Text Summarization and Classification of Conversation Data Between Service Chatbot and Customer.
Yes, sir. Am I audible?
Yes, you are audible.
Yeah, okay. Good evening, everyone. My name is Tanmay Behere, and today I will be presenting our work on text summarization and classification of conversations data between the service chatbot and the customer by me, along with my co-authors Avni Vaidya, Anamika Birade, Kumil Shinde, Professor Pranjali Deshpande, and Dr. Sunita Zahira Badkar. So this would be my today's agenda, as I would go through my presentation, wherein I would start by introducing our topic and our problem statement and what motivated us to choose this topic, along with some of the approaches that we research for implementing the algorithms in our system. Then I would introduce our design methodology and concluding with results and conclusion. So defining our problem statement, given the input data of conversations between the service chatbot and the customer, the system will analyze this data and compute extractive text summary to classify it into one of the three defined categories: help, fake, and fake customer and complaint. Furthermore, a report generation module would also generate reports for each of these three categories to which displays the most frequently occurring problems in each of the three categories. Now, before going into the details of our design system, I would like to lay out some groundwork of what our system is and what motivated us to choose this topic. So nowadays, various companies use chatbot to automate their conversation with the customer, and this data collected online or offline can be helpful for the companies to identify the areas that require immediate attention or the areas where a lot of customer complaints are generated. It might also be helpful to detect flaws in their system and to improve their quality of service. In general, it gives a broader view to the company to design various training programs for the customer. So instead of reading each and every conversation of the customer to analyze his or her behavior and needs, summarizing that conversation to highlight the most relevant and significant details would be more advantageous and useful in terms of time and efforts. So text summarization plays a pivotal role in this scenario because it helps in condensing this large textual information into a concise summary. So the two approaches that are used to implement text summarization is extractive text summarization and abstractive text summarization, wherein extractive text summarization involves pulling of the key phrases from the original text and then adding them as it is into the summary, whereas abstractive text summarization involves understanding the original text and reformulating new sentences to be added into the summary. In our system, we have implemented extractive text summarization to compute the summary of the conversation. So let us now look at the various approaches that we researched for implementing extractive text summarization and classification. First was an adroit approach, which was a combination of statistical approach, NER-based approach, and Q-phrase methods to score the sentences, followed by semantic similarity to reduce the redundancy in the summary. Then next approach was extractive summarization on long documents by combining global and local context, wherein for calculating or computing the global context representation, it used bidirectional gated recurrent units with two hidden states, forward and backward. And for calculating or computing the local context, that is the importance of the sentence in that particular topic segment, it used LSTM minus method, followed by a decoder which computes a value input I, which is forwarded to a multi-layer perceptron with sigmoid function to calculate the corresponding confidence score of the sentence. Then neural extractive text summarization with syntactic compression, which use a bidirectional LSTM for computing sentence and document encoding, followed by a decoder stage, which use sequential LSTM to select the sentences. And to reduce the redundancy of the sentences and the length of the summary, it used various text compression rules. The next approach was fuzzy processing, which consisted of tokenization, that is word level tokenization and sentence level tokenization, followed by pre-processing to remove extra brackets and new line characters or carriage written characters, special symbols, followed by stemming and fuzzy processing, wherein the sentences were scored based on weighted frequency of each of the term in each sentence. However, this approach had satisfactory accuracy to their summary because fuzzy processing works on approximation rather than some fixed value. The next was latent semantic analysis, which was a fully supervised learning approach and represented the contextual usage of words by statistical computations. It eliminated the problem of synonymy by semantic comparison. Now it consisted of following steps: input matrix creation, in which importance of the words in each sentence was calculated, followed by singular value decomposition and sentence selection. The next was a graph-based approach, in which the dataset which they used was midline abstracts with predefined keywords. These abstracts were first pre-processed by their defined rules, and the predefined keywords were used to train the knife-based classifier. Each of these abstracts was constructed into a graph, where the node represented the word, and the edges between two words represented their co-occurrences. Then subgraphs were created based on depth first search, and each of these graphlets, 3 and 4 graphlets, were represented using a 3-digit code, which computed the score of the word. Then finally, knife-based classifier was used to determine whether the chosen word was a keyword or not. Now, the various approaches that we researched for implementing classification was support vector machines, which was a fully supervised learning approach, and then artificial neural networks, which was effective but a difficult mechanism for implementing non-linear behavior, but it performs similar to human brain with enhanced performance through training and repeated improvement and learning. It gave an accuracy of 84.8% in the proposed module. However, ANN required extensive training data sets, and it performs poorly when there is an imbalance between the data sets. Then finally, we searched a multinomial knife-based module, in which it used term frequency for characterizing the text and for making the final prediction, and multivariate Bernoulli module, which depends on binary data. But it concluded that multinomial model performs better when we have limited amount of data, and if the bag of words is large. So going forward with our design methodology, our design system comprised of 4 modules: pre-processing module, which involved removal of noise from the conversations data. Then this conversation data was further forwarded to the classifier module, which was supposed to classify that conversation into one of the 3 defined categories: help, fake customer, and complaint. The classifier in between asks the summarizer for the summary, which performs extractive text summarization on the conversation, highlighting the most relevant features of that particular conversation, which is in turn used by the classifier to classify it into the categories. Then after the category generation, a report generation module was used to highlight for each of the categories, to highlight the most frequently occurred problems in each of the 3 categories and the issues which were faced by the customers. The extraction module was implemented using text rank algorithm, which was purely a graph-based unsupervised learning algorithm. The reason behind choosing this algorithm was graph-based algorithm didn't require any training data set to train the module, and second was graph-based module was based on query-based approach, that is the generated summary represented the user's view. So the steps in calculating and computing the extractive summary was first splitting the conversation into individual sentences, that is tokenizing them, then building the similarity matrix, which is an n by n matrix where n represented the number of sentences in that summary. Now the matrix, the cell value was the cosine similarity between the 2 compared sentences. The cosine similarity computes this value based on the feature vectors. Now finally, after the similarity matrix, the sentences were scored by plotting a graph between the sentences and plotting the graphs between the sentences, and based on the cosine similarity, links were given between 2 nodes. The scoring of the sentences was done based on the number of links incoming to that particular node, and accordingly the sentences were scored. Finally, top n sentences were retrieved, where n was the compression ratio. For our module, we did analysis on the value of n from 1/3, 2/3, and half, and we saw that if the value of n is 2/3, we got the most promising results. The entire system was implemented on Anaconda platform and using Python. where the libraries used were NetworkX and NLTK. Then classification module. The classification module was implemented using knife-based classifier algorithm, wherein first training was done by constructing a count vectorizer, which was used to build the vocabulary of words. Now for including, while deciding which word to be included in the vocabulary, there were two conditions. That is, the word should minimum occur in 2 documents and maximum in 70% of the documents. Finally, it was computed, the count vectorizer was computed and pickled, and it was used to train the classifier. Then TF-IDF was computed for scoring the importance of the words in each of the sentences. The libraries that we used were scikit-learn and NumPy, and NetworkX for constructing graphs.
Yes, Tanmay, please conclude in 2 minutes.
Yeah. Then finally, the report generation module the report generation module used the summarized conversations to generate reports in each of the 3 categories using the count vectorizer. So this is the sample output wherein the extractive summary was computed, and the category which they derived was help. So we used the data that we used to train this model was Amazon Conversations data, chatbot data, and wherein 70% of the data was used for training and 30% was used for testing, out of which it gave an accuracy of 70%. That is, it successfully classified the conversation into one of the 3 defined categories. Now, concluding this, I would like to say that the paper illustrates different approaches of extract-to-text summarization, and taking into consideration the requirements of the design system, it makes use of graph-based approach for extraction and knife-based classification. It would be, so the entire system would be beneficial for companies to better understand the customer needs and to understand his or her behavior. This system can be used by using variant data for movie classification into various genres, news classification, etc. So these are the references that we used in our paper. And yeah, thank you everyone for your time.
Okay, thank you, Tanmay.
Yes, sir.
Just tell me, have you maintained any dictionary?
Yes, we, for the classifier,
just have you maintained the dictionary? Yes.
in the classifier, we have maintained the vocabulary of words.
No, vocabulary of words means you have kept synonyms or what?
No, we haven't kept synonyms. We have kept, as I mentioned, the 2 conditions for including the words in that vocabulary. That is, the word should occur in minimum 2 documents and maximum in 70% of the
So
documents.
you haven't maintained any dictionary?
No, we haven't.
You haven't maintained any dictionary?
No.
What is the size of the vocabulary? How many words were there?
Maximum features were 1500.
1500?
Yeah.
Have you ever referred IIT Powai web page, Dr. Bhattacharya's web page?
No, sir.
For text summarization?
No, sir. I'll surely visit it afterwards.
Okay. In which year you are? Are you a student?
Yeah, I'm a student. I'm a final year student of Cummins College.
Currently?
Currently, yeah.
Okay,
I mean, about to pass out.
Okay, about to pass out. You just visit the web page of Dr. Bhattacharya.
Yes, sir.
You will
surely.
get the more better idea to enhance your work in a more concrete way.
Okay, sir. Yes.
Fine. Rather going for here and there and doing this and that, it will be better to focus on some typical thing and to generate. Right now, you have shown one example of around 10 line chatting was there, 10
Yes,
to
sir.
12 line, and you have brought it to 5 or 6 lines. Okay.
Yes.
So rather bringing it to 5, 6 line, it can be summarized within 2 or 3 lines.
Okay.
Have you done any parsing here?
No, sir. We haven't done.
You haven't done any parsing?
No.
Okay. You just visit that web page of Dr. Bhattacharya.
Okay, sir.
Fine.
Yes, sir.
Okay. Thank you.
Yes. Thank you, sir.
Okay, Dr. Mir, anybody is there?
Yes. Thanks a lot, Tanmay. So I would like to invite Mr. Amit Joshi for the closing remark.
But prior to that, Dr. Mihir, if you do permit me for 2 minutes to just summarize this whole session.
Yes, sure. You please go ahead.
Yeah, a very good evening from India, every author who are present here, all participants. In this session, six papers were planned to present, but unfortunately one is missed. Five presentations took place where the different areas have been touched. The first one was a wireless sensor node related virtual prototype. Second one was associated the comparison of Spark and Hadoop big data analytics. Third one is the IoT based smart plant incubator. Then multiple heart disease prediction based on the logistic regression. And the last one was related to text summarization of the chatbot and customer chat, that conversation summarization. I do like to appreciate the efforts of the students who are just doing their graduation. Particularly, I haven't asked them, but I could guess IoT-based smart plant incubator. They were also the student of Bachelor of Engineering, if I'm not wrong. And this last paper text summarization. These bachelor students have tried their level best to put the good things. I hope all of you have listened it carefully. A lot many ideas can be generated in a virtual prototype. That particular paper can be extended with the actual implementation. The second paper where the Hadoop and Spark comparison was presented, it was some sort of theoretical comparison. If it would have been presented with some example, that would have been better. That can be extension to that paper. IoT based smart plant incubator, I have told them that they do go for the realistic ingredients which are required for the plant growth from farmers yielding point of view. They can extend that one in that way. And that logistic regression, uh, as have been mentioned by Satish, that they did neural network implementation, etc., etc. It will be better to justify their model in comparison with some other body's model, those who have worked on the same 303 database. That would be better. And the last paper text summarization just now have guided them that they can go and they can use the some natural language processing concepts here, because that chatbot customer talk may not take with a particular English grammar. It may be some sort of natural language. They can use the web page of Dr. Bhattacharya for improving their work. Hope to see all of you in the next version of World's for WS4 2021, maybe in a 2021 it may be there. This is what from my side as a session chair. It is over to you, Dr. Me. Thank you, Me.
Yes, thank you, sir. Now, sir, up to you, Mr. Amit.
Okay. A very good afternoon to one and all present here. It's a great time in London. It's summer in London, and I hope if you are in that same area in Europe or somewhere, you must be enjoying this weather. So once again, to other participants who are not from London, good morning and a good evening to one and all present here. And my thanks are due to Dr. Thakur, who has chaired this session and took a lot of pain, a token of appreciation from our team, sir, to you.
Thank
And
you.
look forward to your support and contribution and associations in form of different kind of collaboration with our organizations and at individual levels in future. Thank you very much. And we believe, and I personally believe, that chairing a session digitally is much more difficult than chairing a session physically, because you need to be concentrated on a single screen for a large number of time, and it is difficult sometimes to manage that. And thank you very much for your sparing this valuable time for us.
It's my
And
pleasure,
my
man.
next thanks are due to all the authors who have contributed to this paper. I personally believe that the cycle time of a paper, or for a specifically IEEE conference we talk about right now, is approximately 6, 7, or 8 months, depending upon the processing time. So already you have submitted the paper, then the paper was accepted, you were raised in acceptance, you were raised review comments, you again revised the paper, resubmitted the camera ready paper, you signed the copyright, right now you have presented your paper, and now you will wait for publication. So we just want to announce that we have already submitted the data to IEEE. The e-copyright process is almost over, and if it is not over, we are ready to complete it by end of this week. So we expect the IEEE proceedings to be published by month of October, maybe in the beginning or in the mid. And till that time, please be patient. If we have any content issues or IEEE raises any content issues, we will get back to you in individual capacity, and we will work with you to sort that out. And further, you will also receive your presentation certificate, a thank you receipt, as well as a thank you letter from our organization to you, for your contribution to this conference, and specifically the payment receipt you will receive for your organization's perspective. And thank you very much once again for participating in this conference. And before we close, I think Mr. Mihir will just ask everybody to have their webcams on, so that we can click a group picture, maybe digitally this time, and hopefully we look forward to all to see you in London next year in
Next year.
2021 for WS4 2021. Till that time, stay safe, stay blessed, and stay happy, and contribute to society as and when you can. I believe that COVID-19 will soon be a thing of past, and we will be back to our normal routines as early as we can. Thank you
Hope
very much.
so.
Stay
Hope
safe. And
so.
I think next 10 seconds we will have this video, and then we will just close it up. All the
Yes,
best to everyone.
Yes, we will wait for a few seconds more. We'll wait for a few people. Okay.
Some others are missing.
Yes, few are missing, but let me take a snap. I will share this photograph also with you, as well as a video of this whole session within 2 to 3 days. Thank you, everyone. Have a safe time. Bye-bye.